I arrived at the job site early and began unloading materials. As I was doing so, the homeowner, an elderly couple in their late 70s, approached me. They proudly showed me the new HVAC unit that had been installed the previous day. The couple praised the HVAC technicians for their hard work, but mentioned an incident that had occurred. The foreman had allegedly slapped a cigarette out of one worker's mouth and fired him. After setting up the new electrical meter combo and pulling the service cable, I called for an inspection. The inspector arrived and everything was found to be satisfactory. However, I pointed out a concerning issue with the disconnect installed by the HVAC company. The wires were coming through a knockout with no connector, and both sets of number 10 wires were in the same 1/2-inch hole through brick with no sleeve. During the inspection, we noticed a handyman tearing out a wall. He had attempted to move 2 switch legs and install them in a new box. Unfortunately, he had spliced some old 10/2 underground feeder wire with 14/2 non-metallic building wire, twisted the wires together, and secured them to a stud using a nail. The inspector sternly reprimanded the handyman for his dangerous and unauthorized electrical work. The power company is scheduled to come in the morning to perform the changeover. I am eager to see how the day unfolds, especially considering the electrical mishaps that have occurred so far. When dealing with electrical wiring, it is crucial to adhere to the National Electrical Code, or NEC, to ensure safety and prevent hazards. The NEC provides guidelines and regulations for electrical installations to protect people and property from electrical dangers. Some key aspects of electrical wiring that require careful attention include wire sizing, overcurrent protection, proper grounding, and safe installation practices. Wire sizing is essential to prevent overheating and potential fire hazards. The size of the wire must be appropriate for the amount of current it will carry. The NEC provides tables that specify the ampacity, or current carrying capacity, of different wire sizes based on their material, insulation type, and installation conditions. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on an ambient temperature of 30 degrees Celsius and no more than 3 current carrying conductors in a raceway or cable. Overcurrent protection is another critical safety measure. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that could cause overheating, damage to equipment, or even a fire. The NEC specifies the maximum overcurrent protection allowed for different wire sizes and types of equipment. It is crucial to select the correct size overcurrent device to ensure proper protection without causing nuisance tripping. Proper grounding is essential for providing a safe path for fault current to return to the source, minimizing the risk of electric shock. The grounding system consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel, and equipment grounding conductors that run with the circuit conductors. The NEC specifies the requirements for grounding electrode systems and equipment grounding conductors to ensure effective grounding. Safe installation practices are crucial for preventing electrical hazards. This includes using proper wiring methods, making secure connections, protecting wires from physical damage, and following all applicable codes and regulations. For example, when running wires through walls or floors, it is essential to protect them from abrasion or damage by using conduit or other protective measures. When making connections, it is crucial to use approved connectors and ensure that they are properly tightened to prevent loose connections that could cause overheating or arcing. In the scenario described, several electrical mishaps occurred that violated the NEC and posed safety risks. Firstly, the HVAC disconnect was installed with wires coming through a knockout without a connector. This is a violation of NEC Section 314.17b, which requires that conductors entering a box, cabinet, or fitting be protected from abrasion and properly secured. The absence of a connector could allow the wires to be damaged by sharp edges of the knockout, leading to a short circuit or ground fault. Secondly, both sets of number 10 wires were run through the same 1/2-inch hole through a brick with no sleeve. This is a violation of NEC Section 300.4f, which requires that cables or raceways passing through holes in framing members be protected from abrasion. The absence of a sleeve could allow the wires to be damaged by the sharp edges of the brick, leading to a short circuit or ground fault. Additionally, running multiple conductors through a single hole can cause overheating due to reduced heat dissipation. Thirdly, the handyman spliced all 10/2 underground feeder wire with 14/2 non-metallic building wire, twisted the wires together and secured them to a stud using a nail. This is a blatant violation of numerous NEC requirements. Splicing different sizes and types of wires is generally not permitted, as it can create a point of increased resistance and potential overheating. NEC Section 110.14b requires that splices be made with approved connectors or splicing means. Twisting the wires together and taping them is not an approved method and could result in a loose connection or arcing. Furthermore, securing the wires to a stud with a nail is extremely dangerous and violates NEC Section 300.4d, which prohibits the use of nails or screws to secure conductors in a way that could damage the insulation. The nail could penetrate the insulation and create a short circuit or ground fault. In addition to these specific violations, the handyman's work demonstrated a general lack of knowledge and understanding of basic electrical safety principles. Unauthorized and unqualified individuals should never attempt electrical work, as it can create serious safety hazards for themselves and others. Only licensed and qualified electricians should perform electrical work, as they have the training and experience necessary to ensure that the work is done safely and in accordance with the NEC. When performing electrical inspections, it is crucial to be thorough and meticulous to identify any potential hazards or violations. Inspectors should check for proper wire sizing, overcurrent protection, grounding, and installation practices. They should also be familiar with the NEC and any local codes or regulations that apply. If any violations are found, the inspector should document them and require that they be corrected by a licensed electrician. In the case described, the inspector was correct to reprimand the handyman for his dangerous and unauthorized electrical work. The inspector should also ensure that all of the violations are corrected before the power company performs the changeover. The power company should also inspect the electrical installation to ensure that it meets all applicable codes and regulations before energizing the service. In addition to the specific violations described, there are several other general safety precautions that should be followed when working with electricity. Firstly, always to energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Always use a voltage tester to verify that the circuit is energized before touching any wires. Secondly, wear appropriate personal protective equipment, or PPE, such as rubber gloves and safety glasses. Rubber gloves provide insulation from electric shock, and safety glasses protect the eyes from flying debris or arc flash. Thirdly, use insulated tools. Insulated tools are designed to protect the user from electric shock if they accidentally come into contact with a live wire. Fourthly, never work alone. Always have someone nearby who can assist in case of an emergency. Fifthly, be aware of your surroundings. Look for potential hazards such as water, metal objects, or overhead power lines. Sixthly, follow all applicable codes and regulations. The NEC and local codes are designed to ensure safety and prevent electrical hazards. By following these safety precautions, you can minimize the risk of electric shock and other electrical hazards. In summary, electrical work should only be performed by licensed and qualified electricians who have the training and experience necessary to ensure that the work is done safely and in accordance with the NEC. The electrical inspections should be thorough and meticulous to identify any potential hazards or violations. All electrical work should be performed in accordance with the NEC and local codes. By following these guidelines, you can help to prevent electrical hazards and ensure the safety of people and property. Additional information regarding electrical safety, firstly, is the importance of arc flash protection. Arc flash is a dangerous phenomenon that can occur when a short circuit or ground fault creates a high-energy electrical explosion. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, it is essential to wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields. Arc-rated clothing is designed to withstand the heat and flames of an arc flash. Gloves and face shields protect the hands and face from burns and flying debris. Secondly, ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect people from electric shock by detecting ground faults and interrupting the circuit. A ground fault occurs when current flows through an unintended path, such as through a person's body. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Thirdly, surge protection is essential for protecting electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are designed to absorb or divert excess voltage, preventing it from damaging electronic equipment. Surge protectors are available in various forms, such as power strips, wall outlets, and whole house surge protectors. Fourthly, electrical safety audits are a valuable tool for identifying potential hazards and ensuring compliance with safety regulations. An electrical safety audit is a comprehensive assessment of an electrical system to identify potential hazards, such as overloaded circuits, damaged wiring, or improper grounding. The audit can also identify areas where the system does not comply with safety regulations. Fifthly, regular maintenance is essential for keeping electrical systems safe and reliable. Regular maintenance should include inspecting wiring, connections, and equipment for signs of wear or damage. It should also include testing overcurrent devices, GFCIs, and surge protectors to ensure that they are functioning properly. Sixthly, electrical safety training is essential for all employees who work with or around electricity. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Training should be provided by qualified instructors and should be updated regularly to reflect changes in codes and regulations. Seventhly, lockout-tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair. Lockout-tagout procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on accidentally. Only authorized personnel should be allowed to remove the lock and tag. Eighthly, fire safety is closely related to electrical safety. Electrical faults are a common cause of fires. To prevent electrical fires, it is essential to have properly functioning smoke detectors and fire extinguishers. It is also important to keep flammable materials away from electrical equipment. Ninthly, emergency procedures should be in place in case of an electrical accident. Emergency procedures should include instructions on how to respond to electric shock, arc flash, and electrical fires. It is also important to have a designated emergency contact person who can be notified in case of an accident. Tenthly, documentation is essential for maintaining a safe and reliable electrical system. Documentation should include wiring diagrams, equipment specifications, and maintenance records. Documentation should be kept up to date and readily accessible. In addition to these general safety precautions, there are also some specific safety considerations that apply to different types of electrical equipment. For example, when working with power tools, it is essential to use ground fault circuit interrupters, or GFCIs, to protect against electric shock. When working with extension cords, it is essential to use cords that are rated for the amount of current that will be drawn by the equipment. When working with ladders, it is essential to use ladders that are made of non-conductive materials. When working with overhead power lines, it is essential to maintain a safe distance. The safe distance depends on the voltage of the power line. In general, it is best to stay at least 10 feet away from overhead power lines. By following these safety precautions and guidelines, you can help to prevent electrical hazards and ensure the safety of people and property. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always take precautions to protect yourself and others from electrical hazards.